Our next sequence appears to be geometric. If you can see, the numbers get big really quickly. That's a sign of multiplying. So to get from 8 to 24, it's times 3. And to get from 24 to 72, it's also times 3. So this is a geometric sequence where r is equal to 3. Now, I mentioned the formula before, which we have here, which says an divided by an minus 1 is r. So just to demonstrate that, that means if I take two terms and I take the newer term, so the later one in the sequence, and do 24 divided by 8, I should get 3. If I were to take 72 and 24 and take the newer term and divide it by the term before that, I should also get 3. So all of these things are going to give us 3. For the common difference, we can do the same thing. So d is going to be equal to 7 minus 5. D should also be equal to 9 minus 7. In other words, to get from one number to the next, what did I do? All right, so back and continue this problem. So the explicit formula for a geometric sequence is an is equal to the previous term times the ratio n minus 1 times. In other words, in order to get to the third term, I need to start at the first term and multiply by the ratio twice. So in this case, an is going to equal 8 times 2 n minus 1 times. So if I wanted to find the third term, a3, I would start at 8. So this is my answer, by the way. If I wanted to find the third term, I would start at 8 and multiply by 3. 3 minus 1 times. In other words, I'd multiply by 3 2 times. Multiply by 3, multiply by 3. So that is a geometric sequence. All right, we have one more problem to do, and these are series, also finding specific terms. So we're going to be given a formula. We're going to be given a specific explicit formula. So looking at the first one, I could tell that this is arithmetic. We are asked to find the 12th term, so that just means start at 8 and add 2 11 times, because we're looking for the 12th term. So 8 plus 2 times 12 minus 1, which is just another way of saying add 2 11 times. We're going to get 8 plus 22, which is 40. So the 12th term is 40. Now that's what A12 means. What S12 means is to find the sum of the first 12 terms. So the rule for that is here. So this is called a series, which is just the sum of, a series is just the sum of the terms of a sequence. So Sn is going to represent the sum. The formula is the number of terms multiplied by the sum of the first and last term divided by 2. So in this case, the first term is 8. Well, we're going to be doing 12 terms. The first term is 8, and the last term is 40. And we're going to divide this by 2. So we had to actually find the first term first. So we have to find the last term. We know what the first term is because it's given to us in the formula, but we actually had to calculate the last term. So this is going to be 12 times 48 divided by 2. So we're just going to calculate that. 2 goes into 48 24 times. So this is just 144 times 2, or 288. So that means if I were to write out the first 12 terms of this sequence, 8 and then 10 and so on, I'd eventually get 288 when I added them up. Now for a geometric sequence, it's a little different. So to find the 8th term, that means I'm going to start at 2 and multiply by 4 7 times. That's what's really going to happen here. 2 times 4 to the 8 minus 1 power, which is going to be equal to, trying to draw an arrow. All right, because I'm trying not to do what's called stringing, writing multiple equal signs unnecessarily. So this is 2 times 4 to the 7th power 4 to the 7th is probably a very large number. I'll have to use my calculator on hand to calculate that. 4 to the 7th is, whoops, times 2 is 32,768. You won't really be asked to find the sum of a geometric sequence for too many terms because they're really big. Now, unlike in the arithmetic sequence where you need to know what the last term is, we don't need to know the last term for the sum of a geometric sequence. You just need to know the first term and its common ratio. So to find the sum in this case, I need to know that the first term is 2. I need to multiply 1 minus, I just got to keep looking at the formula to remind myself, 1 minus, the common ratio in this case was 4, so r was 4. The rule was to multiply by 4, it's right there. So 1 minus 4 to the 10th power, that's the number of terms we're doing this for. All of this is divided by 1 minus 4, the common ratio. All right, so all we got to do is calculate this and we'll get the sum of all of those terms. So using my calculator, 1 minus 4 to the 10th is going to be a really small negative number, times 2, divided by 1 minus 4 is negative 3, so, whoops. I get 699,050. So you just have to enter this into a calculator carefully and correctly. So in my calculator, it looks like this when I wrote it in. Let me just get a different color. So on my calculator, I wrote it like this: 2, I put a parenthesis, 2, parenthesis, 1 minus parenthesis, 4. This got its own parenthesis to the power of 10. Close this bracket, close this parenthesis, divided by, and in its own parenthesis, 1 minus 4. And that's what gave me this answer.